Hello students. So in our previous videos we have seen the definition of Laplace transform, the properties, the standard functions, and also we saw three examples of how to solve these Laplace transforms, right? So now today we are going to see or we are going to solve some examples related to inverse Laplace transforms. This we are going to discuss today. Alright, so since I have already defined to you all in my first video what is inverse Laplace transform. So when I define what Laplace transform, we have defined that Laplace transform of f of t is equal to 0 to infinity e raised to minus st f of t dt, which we are also denoting it as f of s, or we are denoting it as f bar of s. So when we have to define inverse Laplace transform, we are defining it as Laplace inverse of f of s is equals to f of t. So this is a simple definition of inverse Laplace transforms. Now, in my previous video, I also informed you as to how we are solving the problems or how these problems are being simpler because of the formulas. So similarly, in today's video also, I'm going to list out some formulas of inverse formulas, Laplace inverse formulas, and that we are going to use it in our examples. So that is what we are going to do today. Now, why we are not proving it is because we've already proved their main Laplace transform. So, for example, Laplace transform of 1 or Laplace transform of t is what? Laplace transform of 1 or Laplace transform of a is a by s. Laplace transform of 1 is 1 by s. Laplace transform of cos at is s upon s square plus a square, right? So now what we're doing, we're going to write it in a reverse form. Laplace inverse of 1 by s is equal to 1. Laplace inverse of s upon s square plus a square is equal to cos at. So here we are not going to prove them. We're just going to write the formulas directly. I'll be listing out the formulas. Do write them and see that you make a separate page for the formulas, because as soon as you open your books, finding the formulas for every problem becomes difficult. So if you have a separate page or a separate book for formulas, it becomes easy for you to compare and solve the problems, and it also becomes easy for you all to study the formulas and to remember the formulas or by heart the formulas. Alright, so let's go to the standard formulas of inverse Laplace transforms. So these are the formulas of inverse Laplace transform. So the first one is Laplace inverse of 1 by s is equals to 1. Laplace inverse of 1 by s minus a is equals to e raised to at. Laplace inverse of 1 by s to the power n is t raised to n minus 1 upon n minus 1 factorial. And Laplace inverse of 1 by s minus a to the power n. So e raised to at t raised to n minus 1 upon n minus 1 factorial. Laplace inverse of a upon s square plus a square is equal to sine at. Laplace inverse of s upon s square plus a square is cos at. Laplace inverse of a upon s square minus a square is sine hyperbolic at. Laplace inverse of s upon s square minus a square is cos hyperbolic at. Laplace inverse of b divided by s minus a the whole square plus b square is equal to e raised to at sine bt. Laplace inverse of s minus a upon s minus a the whole square plus b square is equals to e raised to at cos bt. Laplace inverse of 2as upon s square plus a square the whole square is equal to t sine at. And the last one is Laplace inverse of 2a cube upon s square plus a square the whole square is sine at minus 80 cos 80. Right? So, if you observe this, all on the left hand side are in S and A and B and so on. Whereas on the right hand side they are in the form of t's, or they are in the function of t. Right? So, if I take it reverse, Laplace transform of 1 is 1 by s. Laplace transform of e raised to at is 1 by s minus a. Laplace transform of t raised to n minus 1 by n minus 1 factorial is 1 by s to the power n. So if you see now, if you write either the formulas of Laplace transforms or the formulas of Laplace inverse, you will either from the Laplace transform formulas you will get the inverse values also, and from these inverse functions you will get the values of the Laplace transform also. So if you learn any one, only the Laplace transform, you can easily write the inverse Laplace transform, or if you study the inverse Laplace transform, you can easily learn the Laplace transform formulas, right? So that is that simple. Alright, so now we are going to solve some examples on inverse Laplace transforms. So we have the first example, Laplace inverse of s divided by s square minus 16. This is our first example. Okay, now s divided by s square minus 16. If you see, the 16 is a perfect square and that is nothing but 4 square. So this I can write it as s square minus 4 square. Okay, so this is looking as if it is s upon s square minus a square, right? So can we compare this with any of these expressions here or any of these formulas here? So if you see, it is resembling the 8th formula, that is Laplace inverse of s upon s square minus a square, which is equal to cos hyperbolic 80. So what is our a here? A is 4. So this is how you are going to write it. So the way you are going to represent it in the exam is solution. Okay, Laplace inverse of s upon s square minus 16 can be written as Laplace inverse of s upon s square minus 4 square. So therefore a is equals to 4, right? So this implies Laplace inverse of s upon s square minus a square is equal to cos hyperbolic 80. We know that. So this implies Laplace inverse of s upon s square minus 4 square is equals to cos hyperbolic 40. Very simple, right? So if you know the formula, you can directly write it. But if you don't know the formula, you're not able to solve it. So first thing what you have to do is learn your formulas. That is the main thing what you have to do here. Learn your formulas. Without learning your formulas, you can't solve these examples. Right? Let's move on to the second example. The second example is to find the Laplace inverse of 1 by s square plus 25. So let's find the solution. Now if you see this, it is 25 is this perfect square of 5. So I can write this as Laplace inverse of 1 by s square plus 5 square. But do we have a formula where we have 1 divided by something? Right? So, okay, we have a formula here wherein we have a divided by s square plus a square. Okay, this is looking somewhat similar. So this is equal to sine a t. But when we see the question, we are in a confusion as to whether we have to use this or not. Alright? Now let me give you a small hint here. We can use this formula itself. Now how? By multiplying, or I can divide 1 by a here, and I can divide a here. I can divide a here and I can divide a here. So when I divide on both the sides with a, what I am going to get is Laplace inverse of 1 by s square plus a square is equals to 1 by a sine a t. So I am not changing the formula. It is the same, right? So now compare both of them. Isn't it the same? Yes, it is, right? So what is a now? A is 5. So substitute it. So Laplace inverse of 1 by s square plus 25, or you can say 5 square, is equal to 1 by 5 sine 5t. And this is our answer. Very simple. Yes, a small twist in the question, that's it. Okay, so you should know how to come to this formula, right? So Laplace inverse of 1 by s square plus 25 is 1 by 5 sine 5t. The third problem. Find the Laplace inverse of 1 by s minus 6. So to find this, we have to again go back to our formulas. Now we have a formula wherein we have Laplace inverse of 1 by s minus a is equal to e raised to at. Right? So this is our formula, and if you observe that, we are having the same type of question. So what is a here? A is 6. So therefore, Laplace inverse of 1 by s minus 6 is equals to e raised to 6t. Isn't that very simple? Yes. Let's move on to the fourth problem. The fourth problem. Laplace inverse of 3 by s minus 2. 3 by s minus 2. Now if you again observe, right, so what we have here is, it is similar to this, but we have this extra term called as 3. So this 3, since it's a constant, I can just remove it out and I can say 3 Laplace inverse of 1 minus s minus 2. Right? So now again we are back to the same expression. So we can write 3 into e raised to 2t, or Laplace inverse of 3 by s minus 2 is equals to 3 e raised to 2t. And this is how inverse Laplace transform is very easy to solve only if you know the formulas. I hope the inverse Laplace transforms is clear, the formulas are clear, the problems are clear. You can also try your own problems. You can also try to put the value of A and B in the problems and try to solve it on your own by just putting your own questions. Okay, so you can solve many questions related to inverse Laplace transform. The only funda in solving, you can say, in inverse Laplace transform is you learn the formulas, and it's just a substitution. You don't have to break your head for it. Okay, it's that simple. If you have any doubts, please comment on the comment box. We will try to solve the doubts in the coming videos. And if you like my videos, do subscribe, do like and share it to your friends so who also can profit with these videos. Thank you so much. Hope you have a good day.